Go ahead, Gary.
Okay, thanks, Jean. Appreciate that. And as you mentioned, I'm here with one of my colleagues, John Pannuto, and we'll be talking about tonight's night sky in Waterford. And so one of our goals for this evening will be to show you what you can find out there with the naked eye, or a pair of binoculars at the most, and then be able to go out and find them yourself. Our success is going to be dependent on your being able to do that. So we hope that we can accomplish that by the end of our program here tonight. Let me share my screen here now, and we will go to our program, which is, again, what's up in Waterford's October night sky. You can see that, Jean?
Yes, I can.
Okay, fantastic. And let me flip to the discussion slide here. So the topics that we're going to go through tonight are some of the recent or current comets, meteors, and even asteroids. And some of you may have read about some of those recently, but we'll talk a little bit about those. Then we're going to go into asterisms and constellations, double stars, galaxies, some of the planets that are visible right now. And then hopefully we'll have enough time we can get around to talking about the moon too. But we'll have to see how it progresses, and the questions and everything that come along, and we'll do as much as we can. That one might be a little bit in jeopardy, though, talking about the moon. And if it is, we'll do a program with you in the future. Hopefully, we'll have another one at some point. And then we want to talk a little bit about some of the different apps that you can put on your phone for helping you to find different constellations and objects in the sky, that sort of thing. But as I mentioned, our goal here is to familiarize you with tonight's sky and how to find your way around in it, and find the different objects out there that we're going to look at. And then later on, either go out tonight and see at least 5 objects. Now, we know right now it's kind of cloudy. It's not looking really good for us. But the good thing is that the sky's not going to change too much even within the next week. So if there's any clear skies that are out there even in the next week, most of what we're going to talk about tonight will still be accurate. So let's keep our fingers crossed that we're going to have at least a day or two sometime within the next week that we can go out and do this. But that will be we'll have to just see how that works out. So that being said, let's start out with comets. And some of you may have seen back in July, the July timeframe, comet Neowise. This photo right here, it was actually taken out my back door right here in Waterford, and that was visible with the naked eye. This one was in the early morning, so it was pretty early. I think we had to get up. Oh goodness, I want to say 4 or 5 in the morning. So it was, you had to be a real enthusiast to get up at that time. It was visible later in the month, in the evening, near the Big Dipper. Some of you may have seen it in that case when it was over near the Big Dipper. This was discovered in March of this year, believe it or not. And it's not going to return again for another 6,800 years. The Neowise stands for Near Earth Object Wide Field Infrared Survey Explorer. And it had discovered this earlier this year. So this is my photograph. Here's another one. This was taken by another one of our club members, Dana Towsley, up in Newberry, which is in the Upper Peninsula. And you can see a little bit of it over here on the horizon. I'll show you another one. And these are all stars that were just a brilliant night that when he was out there. Another one that Dana took, you can see Neowise over here, just on the right, the lower right. And again, really clear skies. You can see, can anyone see the Big Dipper in here? Right here. So he captured the Big Dipper and Neowise in the same photo. And as the month progressed, the location of Neowise kind of moved up at the sky underneath the bucket of the Big Dipper here. It kind of moved over in this direction here, and then it kept moving up farther and farther in the sky until it finally just disappeared, I think probably by the end of July or maybe the first part of August. But these were all nice photos that were taken of Neowise. Maybe, John, you can help us out a little bit here with telling the people that are on what actually is a comet.
All righty, thank you. A comet we think of as, like we just saw in the picture, a bright object that we can see in the sky if we're lucky, because it's a naked eye object. We see the tail and we think, well, that's a comet. Well, comets are actually any of the ice balls that are way out in the orbit around the sun out near Pluto in a place called the Kuiper Belt. And sometimes they get bumped out of orbit and by other forces, and then they enter an orbit around the sun in an elliptical orbit, and they come towards us. So they're basically dirty snowballs. They're frozen ice and gases, a lot of carbon dioxide, a little bit of rock and pebbles, and there's trillions of them out there, but we're only accustomed to thinking of them as comets when we see them, but they're always comets, so just out there.
So
does that help, Gare?
Yeah, it does. So how big is one of these, so people can kind of get a little bit of perspective? We're going to kind of compare these three things: the comets, meteors, and asteroids. So I was just curious, how big is a comet?
Comets are frequently fairly small, a half a mile. The biggest ones might get to be a little over 12 miles in diameter. So they're not the biggest objects out there like planets or minor planets or something.
Now, certainly the tail on there is much longer than 12 miles, though, right?
Yeah, those tails can grow to be actually millions of miles long of ionized gases and dust trails. A half a mile doesn't sound like much, but a half a mile coming into our atmosphere would be a major ordeal. So on a galactic scale, they're not very big, but boy, if they came into our atmosphere, it could be a big problem.
Right. And it's probably their friction in their atmosphere, again, that's causing them to glow, I guess. Next, why don't we talk a little bit, to compare that, why don't we talk a little bit about meteors? And interestingly enough, right now is the Orionid meteor showers in October, and their peak is tonight. So we'll show you where to go and find those in just a minute. I'm going to flip onto a different program, but they are approximately peak tonight around 20 per hour. So if it assumes it's clear out. So again, we might not have too good a luck in that regard, and we have a little bit of time. I mean, they're not going to go away tomorrow. They'll be here. You know, tonight's just the peak, but they're still going to be around for probably the next week. And again, hopefully we'll have a clear enough night one of these nights to, or mornings, because actually the Orionids are in the morning. Mostly are going to be there between, say, 4 a.m. and 7 a.m. So before the sun comes up, and maybe some of you are already going to work at that time, you'll be able to look up and possibly see the Orionids emanating out of the constellation Orion. Again, I'll show you in a constellation stellarium program that we have in just a minute here. But let's talk a little bit about what a meteor is now, John, if you can help people with what that is.
Alrighty. Well, meteors is the name that we give to that glowing ball of light that we see coming through our atmosphere. So these are basically little grains of sand or rocks or pebbles They're typically not very large. Sometimes they can be a little bit larger, but for the most part, they're not especially big. However, when they hit that friction of getting into our atmosphere, they actually burn up for the most part. They'll burn up before they ever hit the ground. So there's three different names about meteors. We call them meteors when they enter our atmosphere. When they're outside of our atmosphere and haven't entered yet, they're called meteoroids. And when they land on the ground, they're called meteorites.
So talking about meteors then, we know there's a lot of them that come into our atmosphere every year. Do you have any feel for about how much debris or how much in terms of the quantity in pounds or tons of meteors actually do reach the ground here?
Yeah, it's an interesting thought, because you would think it wouldn't be very large, but meteors are what we see coming in the nighttime, but they also enter our atmosphere in the sunshine when we can't see them because the sun is so bright. So meteors are hitting our atmosphere all day, every day, 24 hours a day. And in a typical day, we'll experience 100 tons of meteors entering our atmosphere.
That sounds pretty amazing, a huge amount. And
unthinkable for me.
Yeah. Yeah, and you'd think there would be a lot more either sightings or damage or people hurt or something like that if you have that quantity of them coming into the atmosphere. But
yeah, we have a question from the audience here from DeRay asking, how far out in the atmosphere is it when the comets are interacting? Do you have a thought on that, Gare?
Well, I mean, they have to be coming into our atmosphere, right? So our atmosphere projects out, several hundred miles at least. So you know that they have to be coming through that because it's the friction, right, John?
Right, when it gets deeper, thicker.
That's causing that. And then some of them will, like we were just saying, some of them come all the way in and reach the ground of various sizes. But usually these are, even those flashes that you see out there are mostly pebble size or just grains of sand size, but they're bright enough because they're streaking at thousands of miles an hour through the atmosphere and creating a lot of friction.
Yeah, so I don't have an exact answer for DeRay, but generally they're pretty high up in the atmosphere, 100 miles at least.
Mm-hmm. And you can see there's a couple more. There's a lot more than just these, say, 11 or 12 here, but coming up are the Leonids in November, Geminids in December, then the Ursids also in December. But these are just some of the different meteor showers over the course of the year and in the month that they occur in. Interestingly enough, the Orionids are remnants of Halley's Comet, which again radiate from the constellation Orion. The ones that occurred in May, the Eta Aquarids, are also remnants of Halley's Comet. John, do you want to tell us a little bit about what that means to be a remnant? I mean, Halley's Comet isn't here right now, and it comes around every 76 years, and I think the next time Halley's is going to be here is around 2061. But so what are we actually seeing?
Well, when that comet goes through our area of the sky, it leaves behind all kinds of little dust particles. And those are the things that we see as we pass through that same section of the sky.
Every year.
Every year on our orbit around the Earth, around the sun, we're passing through that comet dust, that trail of comet dust, which of course tends to spread out over time. And because Halley is a visitor every 76 years, and it's pretty much the same trajectory, it has quite a bit of dust and particles there. So that's why this is one of the better meteor showers.
Thank you. So the next thing that we want to talk about is something that hopefully a lot of you have also read about in the last week or the last few days even, and that's about the OSIRIS-REx mission that NASA had sent up to an asteroid by the name of Bennu. And yesterday, I believe, was the day that it actually touched down on Bennu and took a sample. This mission started, it was launched in 2016. They landed yesterday and took a sample, and it'll now be returning to the Earth, and it'll be back by 2023 with just a 60-gram sample size out of this asteroid. So John, maybe you can help us now with what's an asteroid. Are you on mute, maybe?
Sorry about that. Yeah, an asteroid is certainly bigger than a meteorite, and it's smaller than a comet. The asteroid belt is located between Mars and Jupiter, and there are millions and millions of these smaller bodies out there. Mostly they're made out of rock, whereas comets are mostly made out of ice and gas and frozen carbon dioxide. And of course, the comets, the meteors that we see are the dust and dirt left over from the comet passing. So they're kind of in between, I guess.
Excellent. Let's take a look real quick of where we can find these in the sky. I'm going to flip over to our program here. Can you guys see that okay, Jean and John?
Yeah.
Okay. First of all, let me explain what this is. This is a computer-based planetarium program. And basically what I've done here is I've set the program on tonight's sky in Waterford at 9 p.m. So this is what, if the sky was relatively clear and you were looking into the north, this is what you would see in the northern sky. Some of you may recognize this shape right here, being the Big Dipper. And we'll go through and we'll point out a number of different things in the sky here in just a few moments. But I wanted to point out, first of all, where we would find the Orionids. And let me, first of all, I'll change our time. This is 9 p.m. tonight. So the Orionids are going to be visible from about 5 till 7 a.m. in the morning. So let me change the time here to, essentially at this point it's going to be tomorrow morning, but let me move this to about 5 or about 7 a.m. and we're going to look into the southern sky. I'm going to zoom in a little bit. And so you can see right here, this is the constellation Orion. Some of you may be familiar with that, with the 3 stars in a row and the 4 around the outside. And the Orionids are just above it. So they're essentially going to be emanating out of that constellation, meaning they can go in any direction. They'll radiate out in almost any direction out of that that little spot that you see there that says Orionids. But generally, if you can find the constellation Orion in the southern sky in the morning between, you just went out about 7 a.m., assuming you're maybe heading out about that time to go to work or whatever, you can look in that southern sky, and you'll have to be patient. Again, if it has to be clear for one, and then you'll have to be patient. You'll see about 20 an hour, as I said. That's the peak. So about 1 every 3 minutes is about what you'd be experiencing. But that's where you would find these Orionid meteors. Back over to let's see. Let's go back up to our 9 o'clock tonight, and we're going to look over in the northern sky again, and back to our Big Dipper. So this is where we saw Neowise, was underneath the bowl of the Big Dipper, and it was earlier in the evening too, when it was back in July. It was up over and out here. The Big Dipper was over to the left a little bit more, and it was primarily in the sky right here is where we would have found the Neowise comet. But the sky has changed now. The Big Dipper is lower in the sky at 9 o'clock, and Neowise is no longer visible at this time. But that was an exciting thing for all of us to be able to go out and look at that with the naked eye at that time. So let's begin the talk now about asterisms and constellations. And let's first distinguish between what an asterism is. An asterism is really kind of a smaller subgrouping of a constellation. It's usually a simpler way to identify objects in the sky. I'll show you some patterns here right now that are asterisms. Can everybody see those okay? Gene?
Yep.
Okay. And so these are some of the asterisms that are in the sky, and they also are a portion, like I said, of larger constellations. And you may recognize this one again, the Big Dipper. It's the Big Dipper asterism, and it's a part of, let me show you now, the constellations. So here's the lines for the same constellations, and that's Ursa Major. Big Dipper is a part of Ursa Major, and Ursa Major is the Big Bear, more or less. And these are all, essentially these images that you see in the sky here are Western cultural images. They came down from thousands of years ago in the Greek and Mesopotamia, and early man used a lot of these images in the sky, much more than we do today, to help find things like the seasons, know when to plant crops and harvest them, when do the animals migrate, how to navigate even. They didn't have clocks, they didn't have compasses to be able to navigate and find their way around. This was the most stable, fixed thing that they had in their lives, were the objects that they could see and depict in the sky. And so every culture kind of created their set of images that they saw in the sky. Let me show you actually a little bit more here of what these images look like from the Greek standpoint. This again is the Big Bear, or Ursa Major, the Little Bear, Ursa Minor, Draco the dragon. You can I'll zoom that in a little bit more so you can see the whole thing. Draco the dragon here, which goes really just between the Big Dipper and the Little Dipper. But and then Cepheus the king, Cassiopeia the queen, Perseus, Andromeda. All of these were different mythological images from back in the Greek and in the Mesopotamian times. Ooh, sorry about that. Turn that off. But if I was to look at this, again, was Western culture. Every culture had a different set of images and a different set of stories and myths that they saw in the sky. This one happens to be the Western one. Let's take a look and see what one of the other cultures might be. Let's say, why don't we look at the Chinese? So here's the Chinese one, and you can see it's much more complex. There are hundreds of images that they have in the sky here, and I can't even begin to start describing all of them, but you can see 7 excellencies, the coiled thong, dipper of liquids, celestial kitchen, inner steps, 8 kinds of crops. But here's the images that they saw that made sense to them and that they created their stories around in order to be able to find their way and the seasons and everything. Because all of these, again, they're not going to change. They actually will change over thousands and thousands of years. But what you see here is pretty much the same thing that they saw, and they created these stories and these images in the sky to help them, as I mentioned, to carry on their lives, to find their navigation, to plant their crops, all of those types of things. This was the one for the Chinese. Let's take another look at a different one now. Maybe the Navajo, another kind of North American one. And let's see what theirs is like. So the Navajo, they had two main images. Interestingly enough, do you see the revolving male is also the Big Dipper in our Western culture? Here's the handle, here's the dipper here, and the North Star and the Little Dipper are still here. They don't have anything for that, but they recognize the North Star because everything revolves counterclockwise around the pole star. They also have the revolving female, the lizard. All of these things created their cultural stories around this and how they used the sky and the stars to help them, again, to manage their cultures and their lives. So let's go back to our Western culture again. You can see there's quite a few different ones in here that we can take a look at. But here's our Western culture again, and some of the different images that have carried on for thousands of years and that we still kind of recognize today. And I wanted to help you find a few so that we can go out later and be able to find these on our own. So let's go back to the simplest way we can start looking at these, which would be the asterisms. And again, at 9 p.m. tonight, you should be able to look into the northern sky, and the Big Dipper will be slightly pointing up towards the sky, just above the horizon, not very far. This is probably about 20 degrees, 15 to 20 degrees, something like that. But you should be able to find these 7 stars of the Big Dipper right here. And once you can find that, now you've kind of found a reference set of stars or a guide set of stars that will help you to find everything else in the sky. And that's the key, is you want to be able to create your own map of when I look up there, how am I going to be able to find everything else? So I've found the Big Dipper, and the Big Dipper has the pointing stars right at the front of the bowl here that point directly at the North Star. The North Star being Polaris, it's also the end of the handle of the Little Dipper. And so you can, once you can find the Big Dipper and then find the North Star, you can find the handle and the Little Dipper correspondingly. And the one way to think about the Little Dipper is it's always pouring into the Big Dipper, regardless of what time of day. And let me just show you how these things change as time moves. So there's 10 o'clock, 11, 12, and they continue to move counterclockwise around that Polaris or that North Star. John, I wondered if you might be able to share a little bit with us about why is it called the North Star? What's the significance of it?
The significance is because it's the direction that our Earth is pointing. So if our Earth was spinning like a top, and we imagine a rod going from the North Pole all the way to the South Pole, and that's what it was spinning on, just to get you an image in your mind. But the Earth doesn't spin that way. It actually is tilted in its orbit by about 23.5 degrees. So it actually is, the north is not pointing what we would think of as straight up like a spinning top on a floor. It's actually leaning. So the direction that axis, that north-south axis between the two poles is pointing, that's our direction of north.
That's right. So yeah, if you stuck a pole through the center of the Earth, through the North and the South Pole, that rod would be pointing right there at the North Star.
Mhm.
And so
all of the other stars would seem to turn around it like Gary was showing you. But if
Mhm.
you focused and kept your eyes just on that one star, that would be the only star that didn't seem to move.
Mhm. So you can see how the people in ancient times, when this was the only type of somewhat of a clock or mechanism that you had to be able to depict time of day, time of year, seasons, migration patterns, hunting times, all of those things. This is what they used more than anything, was to look at the sky and the position of the stars on any given time of day during and time of year was going to help them to determine what they should be doing to prepare for the hunting or planting or whatever. So extremely important back then, and to be able to identify these constellations and their relative position next to each other, and then where they are in the sky on particular days, was really critical to them. So we've talked about the Big Dipper, Ursa Major, the Little Dipper, and how to find that by using the pointer stars. And I think it's about 7 distances between these 2 stars here out to the North Star. So we've got the Big Dipper, the Little Dipper. The next one that I wanted to help you find was one called Cassiopeia. Cassiopeia is always very easy to find out in the sky because it looks like a W, kind of a lazy W. And it's on its side right now. It might look a little bit more like a 3, let's say, and maybe when it gets up on the above, it looks more like an M. But basically, it looks like a little like a W. And you can find that by taking the second star in the handle of the Big Dipper and passing through the North Star and continue going about the same distance here out, and there you are, right at Cassiopeia. So finding each one of these, again, if you can find that Big Dipper first, find the Little Dipper in the North Star, now I can find Cassiopeia, and that's directly above. Cassiopeia is the queen. She was the queen of Ethiopia, queen of Cepheus, and Cepheus is the next one that we want to try and find. And it's very easy. We're going to look at it. It's a constellation. Cepheus is right here. It kind of looks like an upside down house, maybe a pencil. Could be, a number of shapes, but it's basically like a square with a triangle on the bottom of it. And so, again, we found Cassiopeia by taking that second star in the handle, going through the North Star, and there's Cassiopeia. Well, basically, right in between these two, the Little Dipper and Cassiopeia, is where we're going to find Cepheus, the king of Ethiopia. These two were king and queen, and they actually had a daughter named Andromeda, and Andromeda is over here. Let's put some of these images in so you can kind of get a little bit better, maybe a slightly better idea of what they look like. So Big Dipper, Little Dipper, Cassiopeia. You have to have a little bit of creativity and leap of faith here, I think, to see these images. But again, these stories were created for them to be able to remember and to be able to pass these stories and myths on to others, and to be able to memorize the sky and be able to, again, find their way around and determine the seasons, etc. So Andromeda is over here. She was married or got married to Perseus, the slayer of the Medusa, and which is in his hand right here. And they both, as a part of a tale or a myth, rode off into the sunset on Pegasus, the winged horse. And this time of year, almost directly overhead at about 9 p.m., you'll see the great square of Pegasus. And that is visible by, again, kind of following the pointer stars all the way up through Cepheus, and pointer stars of the Big Dipper up through the North Star, through Cepheus, and you come up to the great square of Pegasus. And again, Pegasus is going to be huge. It will be much, much bigger than everything else in the sky in terms of the size of the constellation. But there are 4 big stars that create this, the squares of Pegasus here. So we have now the Big Dipper, the Little Dipper, Cepheus, Cassiopeia, Andromeda, and Pegasus. Again, you're finding these all by starting with the Big Dipper. In between the Big Dipper and the Little Dipper, this one's always an easy one, I think, to find, is Draco the Dragon. Draco is this set of stars here. And again, here's the Big Dipper, the Little Dipper, and then this series of stars, it creates the long tail and the body of Draco, and then all the way up to kind of a set of 4 stars that create the head up at the top up there.
Gary, are you going to talk a little bit about the brightness of the stars?
I'll let you go ahead and quote on that or talk about that if you want, John.
Well, I just think it's worth mentioning that some of the stars are clearly easier to pick out than other ones. So you may have heard it said that Polaris is the brightest star in the sky. To tell you the truth, that's pretty inaccurate. The brightest stars in the sky are much brighter than Polaris. But when Gary was showing you how to use the pointer stars of the Big Dipper, and they point towards the star Polaris, it's easy to see it because it's pretty much the only star in that neck of the woods that is bright at all. It's just, it's not particularly bright. So some of these other constellations that we're looking at are fairly dim compared to the Big Dipper. You can even see the lines on the Big Dipper. There are brighter and stronger and bolder than the rest of the stars on the Big Bear. Those stars are not quite as bright as the ones that form the asterism of the Big Dipper. So some of them are definitely brighter than others. And some of them is because they're closer to us. Some of them are because they're very large stars. And so if you have trouble finding the Little Dipper, if you look up, you can find the Big Dipper. As long as you can find Polaris, you're doing good. And if you look at the 2 end stars of the handle, those are pretty nice. I'm sorry, of the pot, Gary, of the pot. The 2 end stars of the pot. Those you can almost always see, and you can almost always see the North Star. But the rest of them, they're fairly dim. You don't always get a chance to see them. When you take a look at Cassiopeia, how much brighter the stars are even on the star chart here. They're easier to find compared to, say, Cepheus. So I don't want to go ahead into the summer triangle yet, but you can see some of the stars are definitely bigger on the screen, and they're definitely bigger and brighter in the night sky as well. So.
Yes, and as long as you're talking about those, that we have the summer triangle right here, which is just to the left of, going to be just to the left of Pegasus, and it's a massive asterism too. It's got 3 in it: Altair, Vega, and the third one over here is Deneb. But those 3 make up the summer triangle. And a part of that is also another asterism and constellation called the Cygnus. And Cygnus is this cross right here, and the wings of the Cygnus, the swan. This is the body here. The head would be over here, and the tail at this end. I'll show you the image there. So this is Cygnus, the swan. So we've found, back again, the Big Dipper. The key thing for us to find first is that, because then that's going to help us find everything else, because all of these things are going to stay in the same orientation to each other all the time. So we need to find these reference stars and guides, and then we can memorize all of the other ones in the sky around it. There are a lot of helping aids now too. We'll talk about that towards the end, where there's some apps you can put on your smartphone that make it very easy, even for a novice, to go up and find all of these objects in the sky just by pointing your phone up there. But we'll try to talk about some of those near the end of the program. So we've got the Big Dipper 1, the Little Dipper 2, Cepheus 3, Cassiopeia 4, Andromeda 5, Pegasus 6, Cygnus 7, the Summer Triangle here 8, and one last one that we can talk about. There's many on here, obviously, that we could talk about, but I want to just kind of do a little bit of a circle around the Polaris, the North Star, and give you a chance to find 4 or 5 of these when you go out. This last one over here is Hercules. It's a bit of a, kind of a square or keystone. It was, I think, typically what it would look like is the center of Hercules here, and that actually has some really interesting deep sky objects that are visible only with the telescope there. But if you make it out sometime to one of our observing star parties, we'd be able to show you that. But there's some globular clusters and that sort of thing that are right in Hercules that are beautiful. So we've taken a look at probably 6 or 7 here. We're hoping that you can at least go out and find 4 or 5. It's certainly the Big Dipper and Little Dipper, Cassiopeia, Cepheus, Draco the Dragon, and have some good luck with that. But we're probably gonna have to wait a few days until the skies get a little clearer. But we'll hopefully get some here in the next week or so. The next thing that we wanted to take a look at, John, unless you had anything else that you wanted to mention about constellations and asterisms?
No, I think we're doing good. We need to make some progress.
Yeah. Okay. Next thing we want to do is we want to talk about some double stars. And there are 2 that are one that's definitely visible with the naked eye, and the other one you can see part of it with the naked eye, and then it has some particular significance that we want you to hear about, that I think you'll find is fun. But the first one that we want to take a look at is one called Alcor and Mizar. John, first of all, what is a double star?
Well, a double star is pretty much what it sounds like. It's when you look in the sky and you see 2 stars right next to each other. Sometimes what you're seeing is an optical illusion. They look like they're close to each other, but it could be billions of miles apart. And sometimes there's stars that circle one another. So that's pretty much all there is.
And I believe are they gravitationally bound to each other?
Some of them are. Some of them circle around each other, just like Earth goes around our sun. Here you have an example of a star going around a star. So those are gravitationally bound, like Earth is gravitationally bound to the sun. But sometimes what you're seeing is just an optical illusion.
Interesting. Okay, so let's take a look at the first one. We said we wanted to take a look at one that's visible with the naked eye. And the first one we want to look at is right here at kind of the bend in the handle of the Big Dipper. And it's a set of stars called Alcor and Mizar. And these are visible with the naked eye. And one of the interesting things about that is over the millennia or many years, this has always been something that was thought of as being kind of an eye test. So if you can see the 2 stars with the naked eye, your eyes are pretty much normal or better than normal. If you can't see the 2 stars, then you're probably maybe your eyes are not quite as good as let's say 20/20 or whatever, and that would be one way of telling the ability of people to see how well they could see. So let's zoom in on that little kind of elbow portion of the Big Dipper. As I mentioned before, that is called the double star Alcor and Mizar. Let's zoom in on that. And do you see it starting to split apart there? And there are the two stars that when I zoom in on it, now you can see Mizar and Alcor. And this is what you might see in a real powerful telescope. But again, you should be able to split these two stars with your naked eye if you have normal to better than normal vision. So let's back out again. And again, I want you to be able to, the key again is finding what? You have to find the Big Dipper first, right? So this is 9 o'clock tonight. Pretty much it's going to be in the same position for the next week or so. But this Big Dipper is going to be key to you finding many of the other objects that we just discussed, as well as this double star in the handle. So write it down, take a picture, do a screen save, whatever, but that's Alcor and Mizar, the double star. The next one that we want to take a look at is one called Albireo. Now, Albireo is, you can see the location of it. Which is, I had shown you before, this summer triangle and the asterism and constellation Cygnus, which is what that cross was but at the very tip here, which is where the head was, if you recall, of the swan, right where that head is. And again, you should be able to find all of these stars with the naked eye. What you won't be able to do with this double star is you won't be able to split this one with normal vision. You have to have maybe you might be able to do it with binoculars. Is that possible, John?
Pretty unlikely, Gary, unless you get some really strong binoculars.
Okay, so it's a telescopic thing that you have to see. But you can see this one star here, which is where it's located. But let me zoom in on, excuse me, Albireo is what it's called. And we're going to see what that looks like. And there's the two stars. It splits these two stars into two different ones that are different colors. You might not be able to see it completely, but can you tell that the lower star is gold or maize? That might be a clue to where we're heading with this. And the top star is blue. These two stars are different colors. One is yellow and blue, or maize and blue. So the other name they give to this double star Albireo is the U of M double, University of Michigan double. And maybe, John, what I'd like to ask you about this is, why are these two different colors, and what do the colors mean?
All righty, that's a really good question. The colors of stars tell the astronomers a lot about the temperature, first of all. So the blue stars and the blue-white stars burn really hot and tend to be quite large. They tend to go through their composition of helium and hydrogen very quickly in terms of the lifetime of a star anyway. So just from the color, we can tell how old the star might be or how long it might be lasting. We can tell something about its age. We can tell its composition of its materials. So the color of the star will tell us an awful lot about the star, which would take us, millions and millions of years to travel to. We can tell just from doing a process called spectroscopy, where they look at the elements of light what colors they see, and the elements that are composite of a star show up in this spectroscopy and tell us a lot about the composition of a star, even though we're far, far away.
Fantastic. I think we might have a survey question here for our audience.
Yes. It's time for a poll to have a short break from looking at stars.
There we go.
So there's a question, how common are double stars?
So all of you can vote on this, and we'll see who has the most insight about double stars.
Yeah, what do you think? How common are double stars? I know I've heard of them before, even before you told us about them, but
Getting almost everybody. We'll see if we can get all 23.
yeah. Take a guess.
That's fantastic.
All right, well,
That's pretty good.
I'm gonna end this.
Okay.
It's been a minute, so let's stop and see.
Okay, it looks like what we got. John, you want to do the honors?
Yeah, I was surprised to see what the answers were, but nobody picked almost all the stars. And that's really a little bit of an exaggeration. It's about 4 out of 5 stars are actually double stars. Just like we were looking at Alcor and Mizar, and we couldn't see the star behind it until we got some magnification. So often we don't necessarily see the second star, but almost every star we look at, 4 out of 5 stars, is estimated to be a double star.
Wow.
Fascinating.
Did not know that. Okay, I'm gonna take this down. Is it gone?
Yes, it is.
Yes, it is. Thanks, Gene, and thank you, John. That will conclude the double stars. And the next thing that we want to take a look at or talk about are galaxies. So we've so far we've touched on comets, meteors, asteroids, asterisms, constellations, and double stars. So the next thing let's take a look at are galaxies. And there are several galaxies that are visible to the naked eye. So first of all, let's talk about our Milky Way galaxy. And I'm going to spin around again to the northern sky. Hopefully everybody can see that. And I'm going to zoom in a little bit. And you can see if I was to look into this northeastern portion of the sky, and again, this is at 9 o'clock. So as the night progresses, it will shift a little bit more, but around 9 o'clock in clear skies, and a lot of times this is visible up north in Michigan. I've seen it many times near the Sleeping Bear Dunes and up near Mackinac and any of the areas where there's less light pollution. It's really good. And then there is actually a dark sky park. It's called the Headlands. It's located in Wilderness State Park, right on the tip of the mitten on the Lake Michigan. So over there you can go and see dark skies quite a bit. It's a designated dark sky area. They're not allowing the light pollution to spoil. But what you see here in this kind of northeast sky, almost directly between the north and the east, is going to be this bit of a dust cloud. It looks milky. It looks, and what these are just the millions and billions of stars within our own galaxy that we can see. And we're looking at these edge on. You know, our galaxy is an elliptical galaxy, or it's a spiral galaxy that has two large arms on it. And think of it almost like a saucer or a plate. And you can look at that plate from many different angles, right? I can look at it straight down at it and it looks like a big circle. I can look at it edge on and it looks more like a sliver. So what we're looking at here is our solar system is located about halfway out from the center of our galaxy. And we're looking back into the galaxy here and edge on of our galaxy. So we're seeing kind of some of the stars that are a part of the plate if I was looking edge on at it. And that's what we're looking at in terms of our galaxy. Let me change over real quick to my PowerPoint, and I wanted to show you a few things there. That here's another photo taken by Dana in our club up in Newberry again. And you can see the beautiful image that he captured of the Milky Way galaxy edge on here. And in reflecting, some of the stars even reflecting down in the water here. Another one where you can see the millions, if not billions, of stars that were captured in this one. Let's get a little bit of perspective here. This is a depiction of our galaxy if I was to look at it, if it was flattened out or looking more like a top down, like a plate. Of course, we can't look at it that way because we're inside of it. But we can look at other galaxies and see those looking like this, like, for instance, the Andromeda galaxy, which we'll take a look at here in just a minute. But our galaxy is thought to be a spiral galaxy. You can see there's two big spiral arms on it here. And our position in the galaxy is roughly about halfway out from the center to the edge. And our galaxy, the Milky Way, is estimated to be 100,000 light years in diameter. Now that's a difficult thing to kind of wrap your brain around, but let me see if I can help or maybe even confuse you further here. 1 light year is the equivalent of 6 trillion miles. So say 6 trillion times 100,000, and that's the width of our galaxy. And it's about 10 to maybe 20 light years thick. So if the plate itself would be that thick. So if we're halfway out, and this is 100,000 across, that means 1/2 of it is 50,000, right? And so we're half of that in 1/2 of those radiuses. So we're about 25,000 light years from the center of our own galaxy. And they don't know exactly, but the best estimates say that there's approximately 200 billion stars in the galaxy, and a star being exactly the equivalent of our sun. And our sun, by the way, is really not even a big star. We're kind of a mediocre, average size star within our own galaxy. So imagine there being 200 billion of those similar size, or some bigger, some smaller, but 200 billion of those in our galaxy. And our entire solar system is located just a fraction around that one little dot. And the farthest object that we had found, or used to be a planet, was Pluto. And I believe Pluto is in the order of 4 billion miles away from our sun. So again, think about that in terms of the size of our galaxy being 100,000 light years, and 1 light year is 6 trillion miles. So the farthest object away from our sun is only 4 billion miles, as great as that is. John, I was thinking this might be a good time for you to talk about your little story about the 15-year-old.
Alrighty, it's kind of a fun one for me. I hope we have some 15-year-olds with us tonight. If this was your birthday and you were born 15 years ago and you had been born with superpowers so that you could travel from the earth radiating like sunlight in every direction simultaneously at the speed of light. Imagine
15 years ago.
15 years ago, traveling 186,000 miles a second of every day of every year, and now you're 15 years old. How many stars do you think you might have passed by in those 15 years?
And that would be 15 times 6 trillion, by the way, right?
Yeah, 15 years times about 6 trillion miles a year. You'd only pass.
I think that's 90 trillion miles away, if I'm not mistaken. I did my math correct.
I can't do that, but
yeah.
The amazing thing to me is after 8 minutes, you would have passed by the sun. On that 15-year journey, 8 minutes into the journey, you'd have passed by the sun. In 15 years, you only would have encountered 71 stars, including our sun.
Wow.
At the speed of
empty out there.
Right. And again, all of those stars are in our own galaxy, right? So again, we're trying to give you a little bit of perspective on the immensity of the size of the galaxy. You're traveling at the speed of light for 15 years in all directions around our Earth, and you only come across 71 stars in our own galaxy.
That's it.
So you can imagine, again, for the light on the one end of our galaxy to come all the way across to the other side takes 100,000 years. And light travels at 186,000 miles per second. So I find that just kind of mind-boggling.
Yeah.
Talked about how big is a light year? It's 6 trillion miles. The next thing I wanted to show everybody was, this is a slide taken by Hubble. Everybody's probably heard of the Hubble Space Telescope, the one that had the problems early on, and then they sent another mission up, shuttle mission, and they got it fixed and everything. And it's a telescope in outer space. But back in 1996, they decided they were going to aim this telescope at a certain kind of bland portion of the sky, I believe near the Big Dipper again. It was a blank area that didn't really show a lot of other things in the sky at that point. But they pointed it at that part of the sky for about, about 12 days, John?
Yeah, about 10 days, yeah. 10
to 12 days. And that's the only thing that it focused on for 12 days. And this is probably the equivalent of looking, if I was to just point my finger at the sky and look at one little dot in the sky for that long. This is what this image was trying to capture. And they took a photograph, and this is that photograph that was taken by Hubble. And all of the images that are in this photograph are not stars. These are all galaxies. Everything in here is a galaxy. And all of these images, they said there's probably the equivalent of, I believe, 5,000?
Actually, 10,000.
10,000 images in here, and every single one of them is a galaxy. So the next question you have to know is, that's coming is, well, how many galaxies are there? We just said that, our own galaxy is 100,000 light years across, has 200 billion stars in it. Now, how many galaxies are there out there? Well, best guesses, again, best scientific knowledge, and we've got our equipment and devices are getting better and better every year, but the best that they're coming up with now is about 200 to 400 billion galaxies. So again, rather mind-boggling so you can see, when I was talking before, here's an image of a galaxy that's kind of looking flat on, right? From face down, so it looks in the plate kind of image. Here's one here where we're kind of looking at the side view of it. But they're all in different angles at different positions, and you can see that they're tilted slightly differently in all cases. And all of these are individual galaxies. So the next thing that I wanted to do is I want to show you one that you can see with the naked eye. Of course, we looked at at ours. Remember, we're back here at our stellarium view where we see the Big Dipper, the edge on Big Dipper, or not Big Dipper, I'm sorry, the Milky Way, as it cuts across the sky. And it'll go from northeast over to essentially southwest. So it'll cut across the sky, going over the, arching across the center of the sky from southwest to northeast. The next one we want to look at, I told you there's one you can see with the naked eye, and that's Andromeda. So it's also referred to as M31. So let's punch in M31, and I want to show you where that is, and I want you to be able to find this on your own. So we had talked before about, again, finding the Big Dipper, using the pointer stars to find the Little Dipper and the North Star, finding Cassiopeia by taking that second star in the handle, going through the North Star, finding Cassiopeia. Well, you can now see why I was kind of refreshing your memory, because if I just keep right on going right through Cassiopeia, I come to this little fuzzy smudge in the sky right there, and that is Andromeda. Now, I've seen that many times with my naked eye. I was out west here last October, probably one of the better places to go because it's such clear skies out there. They don't have a lot of moisture. They don't have a lot of clouds. So it's a perfect place to go if you wanted to do some really good sky watching. The same thing, you can see a lot of it in northern Michigan. You can even see it around here on a nice night. You just don't have quite as many of them. So this is going to be Andromeda. Let's zoom in on Andromeda now, and let's just see what the telescope sees when we're able to have a little bit more magnifying power. So here is Andromeda, and again, we're not looking at it face on. It's kind of a bit tilted, but it is a little bit more side on than face on here, and it's also a spiral galaxy. Matter of fact, they used to say they thought it was twice as large as the Milky Way. Well, in fact, they're now saying, with, again, new instruments like Hubble and many of the better ones that are going up into space, they're saying it's basically about the same size as the Milky Way. So this galaxy, again, is about 100,000 light years across, has about the same number of stars, 200 billion stars in it. And one of the interesting things about Andromeda that I always find interesting is it is on a collision course with the Milky Way. And they anticipate that probably within the next 2 billion years, I'm not sure who's going to be here, but hopefully some form of our civilization will still be around. But this will be colliding with the Milky Way galaxy. You might think, firsthand that that's going to be some kind of a cataclysmic kind of thing. But again, when you're talking about the distances that we were telling you before, where if I took off from the Earth and flew at the speed of light for 15 years, I'd only come across 70 stars in our own galaxy. So there are immense distances between all of the stars, even in our own galaxy. So when these two come together, you can imagine that it's not going to be like two big giant solid objects banging into each other. It's going to be more about a lot of things just kind of passing right by each other. What will happen, though, is there's a lot of gravitational forces that are within the galaxy itself and a lot of the planets and stars and everything inside of it. So a lot of those will start to become gravitationally bound, and eventually I would guess that there's going to be a merging of the two galaxies. But it's not going to be quite the maybe like a cataclysmic kind of explosion or anything. So that is Andromeda, and Andromeda is visible. These are actually other galaxies here too. This is another one here, and there's another one right behind Andromeda right over here. But this is the one that we can actually see with our naked eye. And again, it's not very spectacular with the naked eye, but you can see it. And that's it right there, that little fuzzball. And how do you find it? You're going to go take the second star, go through the North Star, go through Cassiopeia, and boom, it's right there. So, you know, if you can't remember all of these, maybe it gives you a little bit of motivation to start trying to figure out ways to remember some of these different constellations in the sky, and knowing that that's your key to being able to find all the objects and other things that we use all the time. That's still what we use when we go out and we talk with people, do a laser show or whatever. We'll use all of the orientation of the constellations and the stars to each other.
Gary, let me share an interesting tidbit here too about that galaxy.
Mm-hmm.
If you zoom out, so that we're looking at a lot of stars now, it was not apparent for the longest time that that galaxy really represented something outside of our galaxy. It was not until the 1920s that it was actually proven that what you're seeing there was not some stars that were part of our galaxy, that it was indeed another galaxy. It was discovered or proven by a fellow named Edwin Hubble, whose name I'm sure you recognize. But I mean, that's 100 years ago or so. People still didn't realize that ours was not the only galaxy. It's
right.
Amazing, the progress or the changes that have taken place in 100 years.
I think we have another survey question.
Yes.
About galaxies here. Maybe you can bring that up, Jean.
We have another poll about.
We have one about the stars. That's one you're thinking, Gary?
Yeah, all the stars in our galaxy.
Yeah. Mm-hmm.
Location of stars.
So let's see.
So the question is, all the stars that we see with our eyes at night are found in our own galaxy. True or false?
And so far, people are saying false, and it seems like from what you were saying that it might be false, might be the answer. I don't know. Or actually, I'm going to change my
3-1.
I changed my mind. I think from what you were saying, true would be the answer. I don't know.
Okay. Well, let's see.
My mind has completely been boggled by all these distances and numbers of galaxies.
Yeah, it is pretty mind-boggling, isn't it?
Okay, I'm gonna end the poll right now.
Okay.
So there it is.
John, I'll let you do the honors.
Yeah, it says all the stars we see at night are found in our own galaxy. It's true. The only stars we can see at night, every one of those stars you're seeing are stars in our own galaxy.
We can't see any stars in the other galaxies. We can see other galaxies, but we can't see any stars in other galaxies.
With our naked eyes, right?
Yeah,
so we're talking about, yeah, you can see some glow from the Andromeda galaxy, so it's confusing. And you say, is that a star or is that something else? And the answer, of course, turns out it's something else. But all those other things you see up there, they're all stars, and every one of them is in our own galaxy. One of, what do we say, 200 billion stars, right?
Correct.
Okay, well, I'm going to stop this poll, but we have a couple more polls coming up, so watch for those.
Yes. Thank you. So, okay, we've now talked about goodness, where have we been? We've talked about comets, meteors, asteroids, asterisms, constellations, double stars, galaxies. So the next thing that we want to talk about, which are probably some of the more fun things right now, to go outside and see our planets. So let's see what's out there right now. The three planets that are very prominent are Mars, Jupiter, and Saturn. They're so prominent that they're almost impossible to miss. If it even on a night when it's not real clear out, they're going to shine right through the minor clouds and that sort of thing. They will be blocked if it's really cloudy out, but all three of them are so bright right now that they'll be the only thing sometimes that you'll see. You won't see any stars before you'll start seeing the planets out there. And they usually will be some of the first things you'll see at dusk because they're so bright again. But let's start with Mars. Maybe it would be helpful also for us to take get a perspective on our solar system really quick. And so we all remember that Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. We used to have Pluto, right? And it got demoted. Why did it get demoted, John?
It got demoted because it didn't do the job that a planet does. You know, the more we learn about things, the more we have to refine our thought process. So at first, you know, we didn't even know there was another galaxy out there. Well, the same thing kind of happened with the planets. So we're looking at them and we're saying, wow, is there more than just the planets that we can see? And they mathematically figured, yeah, there's Neptune and Uranus out there. And then somebody calculated that there ought to be another one, Pluto. They're still looking for planet X out there somewhere. But
yeah, and I think one of the things that they were saying about it is that a planet, to qualify as a planet, there are 2 or 3 different criteria. One of them is that it had to clear the area of its orbit of other debris and objects and that sort of thing, which means it had to have its own gravity magnetic field, and it would gather the other things in its orbit accordingly. Well, that's one of the things that Pluto couldn't do. So it got demoted because of that. But here are the planets here, and we're talking about these 3, Mars, Jupiter, and Saturn. Let's get a quick idea of kind of the relative distance from the sun for each one of these. And interesting perspective that they put on here is how long would it take for light to travel from the sun to each one of these? As John mentioned earlier, it takes 8 minutes and 19 seconds for light to travel from the sun to the earth. Remember, the speed of light is 186,000 miles per second, and we are 93 million miles away from the sun. So you can kind of, if you can figure out the number of seconds and want to do the calculation, I assure you it will come out to around 8 minutes for a particle of light to come from the sun to us. So what does that mean in terms of that light that we see, John?
I'm sorry, I was distracted. I was typing a long-winded answer to somebody's question in the chat window.
No, okay, I'll take the honors. It basically means that we're seeing something in the past, right? That light is 8 minutes old. It's not happening right now. So as far as we know, that the sun could not be there because the light we're seeing is 8 minutes old. Similarly, that light that we're seeing from out in our own galaxy, coming from the other side of our galaxy, or even the light from Andromeda, that Andromeda galaxy that we just looked at, that's 2.5 million light years away. Okay, so again, let's think about that for a second. That means it took that light that we're seeing from Andromeda at the speed of light, it took 2.5 million years for that light to get to Earth. So big question, you know, what could have changed in the last 2.5 million years? You know, that light is 2.5 million years old that we're seeing. So again, an interesting question to ponder. But let's look at these. 93 million miles from the sun is the Earth. 141 is Mars. let's just say a 500 million or 500 million for Jupiter, and close to, we'll just say close to a billion, 900 million to a billion miles for Saturn, almost 2 billion miles for Uranus, and almost 3 billion miles for Neptune. And I think I mentioned before when we were talking about the size of our galaxy that Pluto is about 4 billion miles away from the sun. So these are all relatively close to the sun. And what's the significance of the first 4 planets as opposed to the last 4 or 5, John?
It's kind of interesting that it turned out this way, that all of the 4 planets, of which we're the third, are all rocky planets. And so they're things that we can actually stand on, and they're composed of dirt and rock. But all the other 4 planets, the farther ones out, are all principally composed of gas. Now, they're really immense planets too. So that gas actually, with the tremendous pressures there, actually turns into liquid at their center. But mostly what we can see is all gas. So rocky planets, and they call them gas giants.
Great, thank you. A fun thing I just did yesterday. I want to show you something here. I went up to, my wife and I actually went up to the Père Marquette Rail to Trail up near Midland. And we rode the trail from Midland to Clare. And one of the fun things on that trail, it's relatively new, I think, it hasn't been there for a long time, is that they have a model of the solar system. And so starting at one end, they have the sun, which that sun, I think it's probably, I would say 8 to 10 feet in diameter on this post here. And it starts there, and then next to each of the objects, all of the different planets of our solar system are there. They have one of these little barcodes. And if you take a picture of that while you're standing there, it takes you directly to the NASA website, nasa.gov, and everything that they have, pictures, as well as all of the critical facts about the sun. And then as you go on the trail, down the trail, and this model goes out about 5 to 6 miles before you get all the way out to the farthest planet, which is Neptune right now. So 5 miles away, and these are all proportionately correct, right? So the size of the planet itself, as well as, and this you can see, Mercury is just a little. It was probably not much bigger than a pea. Whereas when we got to Jupiter, that was probably about the size of a basketball. And Saturn was maybe a volleyball. The Earth was probably the size of a cherry. But they're all on these little posts, these stainless steel posts, and they have these little barcodes that you can take a picture of, and it'll tell you, well, here's how far this actually is from the sun. Here's the diameter and the temperature and all the critical things about it from the NASA website. But a very cool thing to do if you ever have the time, and I would highly recommend it. I'll be going back for sure. A lot of fun. So let's start with Mars here. Let's go back to our planetarium, and let's start with Mars. So again, we're talking about 9 o'clock tonight. So in the north, actually in the eastern sky, is where we're going to find Mars. And Mars is going to be up at about, 25 to 30 degrees above the horizon. It will be very bright. What's one of the prominent features, John, that we will notice about Mars? Are you still there? John, you're probably muted.
If I wasn't muted, yes. Sorry about that.
No problem.
Yeah, Mars is particularly red looking. So if we were looking at it, first of all, we look at Mars, Jupiter, and Saturn. They all look like twinkling stars, don't they? Or bright stars, not really twinkling, but bright stars, very large, bright stars. Comparing Jupiter and Saturn to Mars, Mars is distinctively red. And the reason why it's red is not because of its namesake. It was named after the god of war, the Roman god of war, Mars, with the concept of it being a bloody place. It's actually red because of the preponderance of iron minerals that are on the surface and in the atmosphere of Mars. And so over time, a long time ago, when there was oxygen and water on the surface of Mars, what we're looking at is a hue like of rust. The color red we see is from rust formed on the planet of Mars.
Thank you. Excellent. And these two white dots off to the side here are both moons of Mars. And they're considered the twins. They're called Deimos and Phobos, and they're the twins of Ares, the god of war. And Deimos and Phobos also mean fear and terror. And so they are meant to strike terror into the hearts of any enemy that might come up against Ares or Mars. And so there are two moons of also of Mars. And the other interesting thing about Mars are there's a couple of very large craters or crater fields, as well as canyons on Mars. And these canyons, originally, they always thought that these were rivers. Early on, when they were studying Mars, the early part of the 20th century, they thought that these were actually rivers and streams and canals that some being on Mars might be traveling on. Well, of course, those things all got dispelled as soon as the equipment and all things that we use today were able to get a closer look at it. And it's actually quite desolate. There's no known living things there, although they're thinking there could be something that lives beneath the icy surface of it. There potentially could be some type of microbial life, and that's what all the excitement is about in terms of trying to send some either astronauts or probes there to bring back samples or something beneath the ice cap. And this is the ice cap down below here, the canyons, as well as the some of the giant craters. But that's Mars. And again, let's make sure that we all understand where we're going to find that in the sky. I'm going to zoom back out again. And we're looking at, remember, the eastern sky at 9 o'clock, probably about 30 degrees above the horizon. You'll be able to see the brightest dot in the sky at that point will be Mars. And you can't miss it because it's also going to look rather orange or red. And again, for the reasons John was mentioning, there's a lot of iron in the soil content of Mars. So that's where we'll find Mars. I'm hoping you'll all be able to go out and do that now.
Gary, we're getting close to stopping time here. It's a little after 8:30 already, if you could believe that.
Okay. Gene, shall I talk about Jupiter and Saturn and we can wrap up?
Sure.
Okay. Let's just quickly go through these. I wanted to show you where to find Jupiter and Saturn too. So in the southern sky, a little bit to the southwest, maybe a little bit lower in the sky than Mars, is where both Jupiter and Saturn are. So south to southwest, but maybe about, say, 25 to 30 degrees above the horizon. There'll be two large images there in addition to the moon itself. But Jupiter is the larger of the two. Let me zoom in on Jupiter really quick. And we'll try to make this quick, faster than before. And you notice that Jupiter, our largest planet, interestingly, it has the stripes on it, which are really because of the planet itself rotating at such a high speed and having storms and being gaseous, it creates a lot of the image that you see here. Typically you can see 4 of the moons of Jupiter. That's Io, Europa, Callisto, and Ganymede, which is actually behind the planet right here in this case. But Ganymede is actually the largest moon in the entire solar system, so large that it's actually larger than the planet Mercury. But it doesn't qualify as a planet itself. It's in orbit around a planet of its own. So Ganymede is one of the ones that, again, is the largest. The other interesting thing, we typically see 4 moons here, and we do that. Even when we're looking through our telescopes, we see the same thing. But the planet Jupiter has 79 moons. And believe it or not, it's not even the one that has the most moons. We'll look at Saturn here. Let's take a quick look at Saturn. And again, I want you to be able to find these with the naked eye. And again, they're both going to be right next to each other. And Saturn will be slightly above and to the left of Jupiter. I want to say maybe 5 degrees, 5 to 10 degrees to the left of it and a little bit above it. And smaller. It's going to be slightly smaller. So let's zoom in on Saturn here now really quick. And again, we can see Saturn. And maybe, John, you got a minute here, you can tell us real quickly what some of these different things we see about Saturn. And then we'll try and wrap up.
Okay, well, in addition to all the moons that we're seeing there, of course, the big show on Saturn is its rings. And the rings are not always visible to us. When Galileo first looked at the planet Saturn through his telescope, the rings were tilted in such a fashion that he was looking straight on like a plate. He couldn't even discern that they were rings. It wasn't until about 40 years later that it became more apparent from another astronomer that those were actually rings. And it wasn't a long time until we spent a spacecraft out there, Juno, and were able to look at some of those rings in detail. They're mostly made up of little chunks of ice, small rocks, sometimes a little bit bigger rocks, but not particularly as massive as it looks. Those rings are less than a couple of miles thick, but they're very, very wide. They're 175,000 miles wide, and they're highly reflective because of all the little chunks on them.
Mm-hmm. Thank you. Now, we were talking about the moons. There are a whole bunch of moons you can see here: Enceladus, Rhea, Dione, Tethys, Mimas. Titan is another one. I think it's probably behind the planet right now, but Titan is the 2nd largest moon in the solar system, behind Ganymede of Jupiter. And the interesting thing enough is that Saturn, even though it's smaller than Jupiter, has more moons. We said Jupiter had 79 moons. Saturn has 82 moons, believe it or not. So it is the king of moons, even though it's not the king of planets, so to speak. I think we have one more survey question, and then I think we can wrap up, Jean. Okay.
Do you want to do the
favorite planet one?
I was thinking of the moon one. Only which one is true?
Okay, we can do the moons.
Yep.
Okay, so only one of these is true about moons. All planets have moons. No planet has more than 4 moons. One planet has 82 moons. And is this a trick question?
I might have given it away.
I think Gary was just saying.
Yeah.
Let's see if you were paying attention.
Yeah, there it is. If you weren't paying attention, you're going to flunk.
But this is a trick question, because even though one planet has 82 moons, a lot of people think, or at least 2 do, that all planets have moons. Is that true, Gary?
It is not.
Oh. Which planets don't have moons?
Mercury.
Right.
And Venus, I believe.
Correct. Mercury and Venus don't have any moons.
Huh.
Yet
Well-
all of the other ones have at least one. We have one, Mars has two, right?
Yep.
Okay, I'm gonna end the poll.
Mm-hmm.
And, well, a lot of people were paying attention.
Yeah.
That's good.
That's a good sign. Okay, well, fantastic. I'm going to wrap up my part of this right now. And I certainly hope everybody learned a few things. And again, my biggest hope was that you're going to be able to go out. Maybe not tonight. The weather wasn't cooperating with us as much as we would have hoped. But please go out sometime this next week and see if you can find some of the things that we talked about in the program tonight. We had hoped to talk about the moon, but maybe we'll do that in one of our future programs if we do some more with Jean and the library. So
Yeah.
if we do, please tune in, and I hope you enjoyed it tonight. Jean, I'll hand it back to you.
Okay, well, thank you. Well, now, but were you gonna tell about how they have apps on? There's apps they can.
Yeah. Would you like me to do that? I can do that really quick. Let me do that. I will go back to my PowerPoint. And
Sorry, it's just that it seems interesting and very helpful if there was something that right on your phone that you could use to help you.
yes,
This stuff.
please, this slide will help you a lot, I think. But we have a website, Oakland Astronomy Club. But down here, there's a number of free apps that you can download, put on your phone. Sky Portal, Skyview, Redshift. They're just three of many. You can actually just ping the Apple Store, one of those, and there'll be all kinds of them that show up. But all of these are apps that are free. They're very powerful. All you really do is call up the app and point it up at the sky, and it starts telling you all the different names of the stars, the planets, the constellations, and very easy to use. Great for using in the campground if you're out on a camping trip or even out on a hike someplace at night. But please try to download one of these. Another one of my favorites is the ISS spotter, which is the International Space Station spotter. That's another one where NASA created this, and it's free, and it tells you when the International Space Station will be coming over. It doesn't come over every single night, and it's not always in the same place, but it'll tell you when, and it has alerts that it can tell you, 5 minutes or an hour before time that, hey, I'm about to come over, make sure you're out at this time, looking at this part of the sky, and you'll be able to see it going across. It's a very cool thing. I never get tired of it, but these are all things that you can certainly try to use. And I believe, Jean, you're recording this, and I think you're going to put it out on the website or something like that. So this information will still be available to everybody if they wanted to come back, right?
Yeah, I'll figure out where to put it and how to let people know about it. But yeah, we do have a recording of it. So
very cool.
Thank
Yes,
you.
snap this screen or take a picture of it with your phone or something. I'll leave it for another second here. But thanks again, everybody. It's been a lot of fun. I hope we can get together in person at some point, and we'll really be able to show you some of these objects real time.
Yeah, hopefully, maybe in like 2021 or 2022. Who knows when it may be? But anyway, thank you. Well, thank you, Gary and John, for all your fascinating knowledge and for sharing it with us. And thank you for coming into the library that day back in February and offering to do a program.
Yeah, we enjoy it very much, and hopefully we've converted a few, and maybe we'll inspire a few to go out and look at the night sky.
Yeah, exactly. So, and thank you everyone for showing up at your own house and for participating. So I think I'm gonna
sign off.
It's getting close to 9 o'clock, so I am going to end the program.
All right, thanks, Jean. Thanks, everybody.
Thank you.
Good night.
Bye.